cinder cones. We've got a really great example here that chlorine has exposed for us pretty extensively. We've got the flanks exposed. You can see a really impressive trend that reveals how this volcano evolved, at least in terms of the material that it ejected. We've got another vent over here. Part of that has been cored. You can see the tracks along its surface. And there's another vent on the other side of the plus. We've got a cluster of 3 vents describing this little cinder cone field. And then off to our east, we've got exposed in the cliff over there, lava flow. What do you think that cliff represents? That's another fault. But things are looking a little different this time on that fault. We'll worry about that stop QV in just a few seconds. Let's go ahead and take a peek at page 3. Page 3 is a bit more of your detailed view, your shaded relief map view. We identified stop number 1 on it. We're now over about to the right side of that map near the bottom. I'm going to write in stop 2A. And if you see at the bottom, it says pole line. And actually that's cut off a little bit. That's Pole Line Road. And just to the left of the P, there looks to be 3 little hills. See that cluster of 3 hills there? And those 3 little hills have these little dents in the top. Well, the dent in the top of those 3 hills, that represents the summit crater of these cinder cones. Okay.
Which is right here? Oh, right here. Yeah.
Oh, you're right at the bottom line.
So what's the cinder cone?
They're the little round bumps that look like they have the dents in the top there. Does everyone see where those are?
Is that stop 2A?
That's stop 2A. And we're at the northern one that has the best dent, the best summit crater. It turns out it's a real easy walk right around the corner. The quarry actually has kind of a ramp that goes right inside. And we usually, when I run my field trip out this way, we usually go up to the summit and you get a nice view at the northern extremes of the Hack Creek Valley. And you can kind of see that on your shaded relief map. If you're facing the cinder cone, you're looking north, so the map is oriented properly for you. And at the top, you'd actually look towards what is Saddle Mountain. That's the biggest bump on this particular map. And then you can see how the Pitt River moves through the map area before dumping into Lake Britain.
Which is north?
The bottom right's got that arrow
There we go,
set
thank
there.
you.
Yeah. These are set up, most maps, but not all. There's a couple that aren't quite this way, maybe in the handout. But if you can read the words, you've got it oriented so that it's north is up. One of the things that I want you to notice is around our cinder cones there's a real rough texture in the shaded relief map. That really rough texture represents Cinder Butte lavas that we were just driving through. Cinder Butte is off the map in this one, but it is on map 2. So let's go ahead and flip over to map 2. You'll see Cinder Butte. And actually, you can see our cinder cones pretty well right next to the words 6 Mile Hill elevation 3941. That's stop 2A again. But look where Cinder Buttes are. Almost dead center of the map. Cinder Butte is a rather young volcano. This one, less than 10,000 years in age. And it's partly associated with this relationship with what's known as the Hack Creek basalt. The Hack Creek basalt is really well constrained in terms of its age, coming out of Old Station. Hack Creek basalt comes out of Old Station area and flows north towards Cinder Butte. and Cinder Butte actually overlaps some of the Hat Creek lavas. So this is a pretty young volcanic field. The cinder cones are pretty young. They've got nice form. They're not heavily treed. They're not eroded extensively. You can imagine stuff like this doesn't last very long, especially in climates like we have here, right? So these are actually very young vents. I also want you to notice that in map number 2, the lavas from Cinder Butte, they reach up to these cinder cones and beyond. Can you see that texture moving beyond? Let's go ahead and go back to page 3 now and follow that texture a little bit more. And now you see that really rough texture. See where it says Castle Fall River Road? That's about the limit of the lava flow, near there, isn't it? Extending from that series of words, Castle Fall River Road, there's a whole bunch of linear features. What do you think those are? Yeah, those are faults, aren't they? And as I start drawing a few of these in, I'm going to draw them in with my felt marker here. You really start to see all kinds of features moving through this area. And we're actually a little bit farther east now, of course, from Rocky Ledge. But as I start drawing these in, they just are everywhere. So I've got a whole series identified through this section. Every linear feature that you see on this map is a fault. It's a fault. Now what's interesting about these faults, yes, they absolutely are. We'll talk a little bit more about the ones farther to the east. But I've got lots and lots of lines drawn through, right through here. Notice they die out beneath the Cinder Butte lavas. And it turns out even our cinder cones here sit on top of those fault trends. And the fault trends all moving down this way. So what's older, the faults or the cinder cones? Faults. What's older, the faults or Cinder Butte's lavas? Faults. Yeah, because they're buried by that activity. So one of the things that begins to jump out over here on the floor of the valley, we're still really on the floor. Once we start going up that scarp, we're coming out of the valley and we're moving towards the adjacent valley, which is Fall River Mills Valley. And so we're almost to the eastern edge of the Hat Creek Valley now, at least in its northern extent. And that is faulting over here, mostly associated with the floor, is tied in with some of this younger volcanism. Okay, we'll pick up that story a little bit further along as we move over our next couple of stops. Let's have you guys glance now at page 5. We haven't dealt with page 5 just yet. And let's deal with a table down below first, titled Forms of Volcanic Products. It turns out volcanic materials, erupted materials, they get categorized based on size, in part, and based on their character in terms of whether or not they're solid or liquid on the way out of a vent. And so our liquids, our molten rock, of course, falls under the category of lavas. Lavas are commonly described in terms of their characters, whether or not they're blocky lavas or whether or not they're smooth lavas. The smooth lavas are known as pahoihoi, and the blocky lavas are the a'a.
This is after they've cooled and hardened?
This is after they've cooled and hardened to some extent, although I'm going to back up on that one, Jay. It turns out you can absolutely observe pahoihoi lavas and a'a